दोस्तों जय हिंद जय भारत नमस्कार. With this particular session, during this particular session, we will try to understand how VSD leakage current can be calculated and in what parameter it depends. Again, as usual, this is an educational video and we have no relation with any company, any product. This is only for my friends, those who want to learn the VSD and other equipments, VSD leakage current calculation. Now, this is the story what we have discussed in last session. Point of common coupling and leakage current is flowing through the other equipments also. But this particular leakage current, on what parameter it is been depends. We discussed the how we can avoid the sideband tripping by absolutely using by an attuned EMC filter. But let me try to explain in this particular session on what parameter this particular leakage current is depends. The first parameter is nothing but our DC bus level. The DC bus level, the magnitude of the DC bus level, uh, the magnitude of the leakage current is directly proportional to the DC bus level. The increment in DC bus level, the I leakage will be increased. The leakage current will be increased. The second parameter, it is nothing but by dV by dt generated by the IGBT. This dV by dt depends on the IGBT manufactured by the OEM, the system parameters and other many effects. So we need to see how much dV by dt is being generated by the IGBT. This is the second parameter, and the third parameter is nothing but the switching frequency set by the OEM at the VSD controller. If you are changing the switching frequency at the VSD controller, you need to see how much leakage current is flowing. Otherwise, the side-by equipment may affect. The fourth parameter is nothing but the type of filter used as the VSD output. There is a dV by dt filter, there is a sine filter, there is nothing at in between VSD and the particular motor. Number of cables, again this is the fifth parameter, output cable impedance and capacitance, and most important thing is ground inductance of the grounding system and the shield being used by between the VSD and the motor. All these contributing parameters are responsible for generating the leakage current. But our leakage current has a two property. It is not so simple. The leakage current depends on first parameter. Let me try to give one formula. So leakage current depends on the leakage current peak. मैंने यहाँ पर I have mentioned I leakage peak. Maximum leakage current is nothing but the DC link voltage divided by the system impedance. In this particular case, the system impedance is nothing but the number of run cable between the VSD2 motor, the capacitance, the motor capacitance, the grounding inductance, everything. It is nothing but a system impedance. Now, if we have a 400 volt AC system and that approximately 600 volt DC bus level is there. So, in case of in case of this particular VSD rating is less than or equal to 100 kilowatt, the I peak leakage current, the thumb rules, I mentioned the thumb rules only, it is in between 10 to 30 ampere only. But if in this particular case, if the rating is 100 to 250 kilowatt, the leakage current, the I peak value 30 to 100 ampere, and in case of 250 to 800 kilowatt nowadays, the current may reach 200 to 300 ampere. This is I peak. For a few millisecond, few microsecond, it may touch this value. This is for your thumb rule calculation. But if you consider the leakage current has been two components. One component is called true RMS value and second one is called the peak value. Now left side I have mentioned the true RMS and the peak value. Any leakage current has a two value. One is called true RMS value and second is peak value. The true RMS value is approximately 1/10 of the peak value if the cable distance is within 300 meter between the VSD2 motor. Please listen carefully. If the distance between the VSD2 motor is less than or equivalent to the 300 meter, the true RMS value is 1/10 of the peak value. The true RMS value will increase if you change the switching frequency at the VSD controller. Mind in when you are commissioning the VSD, and the true RMS value will increase if you alter the number of VSD cables and type of the cables. Number of cables are more, the leakage current true RMS value will be more. And that is why we insist a special grade VSD cable where the capacitance value is extremely low, so the leakage current will be low. In case of peak current, the peak and RMS value of the leakage current is directly proportional to the magnitude of the DC bus level. That means if you alter the DC bus level, if you increase the DC bus level by some means, the leakage current and leakage current RMS value and peak value both will be increased. The peak value is not depends on the switching frequency or cable distance. For kind information, the peak value is directly proportional to the DC bus level only. But the true RMS, yes, I agreed, the true RMS value of the leakage current depends on the switching frequency. The peak value can be reduced if you use the proper VSD filter at the output, either du by dt or any other type of filter at the VSD output. So leakage current can be reduced. So when you are selecting the output filter, kindly refer the OEM catalog. Um, don't try to use a local filter, otherwise the side by equipment leakage current issue will be faced. So the peak current value, the magnitude of the leakage peak can be reduced if you use a proper VSD filter at the output. And because all this above problem everyone is facing, ELCB and RCCB malfunctioning at the VSD input, because of the leakage current is not calculated during this particular design. And this leakage current, if you have used the ELCB or RCCB type of protection at the VSD input, the tripping of ELCB or RCCB will make asset deterioration, make you production loss, and then you will not find anything. You just reset the ELCB RCCB, it will again run, and then after few days, once there is a peak value, and then again it will trip the particular ELCB oblique RCCB. Now, to understand this, if you are using the ELCB, even though if you want to use the ELCB, now there are certain calculations, there are certain thumb rules I will mention. If you are again using RCCB, ELCB or earth leakage relay type of arrangement at the VSD input, for the 0.5 kilowatt or less than 0.5 kilowatt VSD, the ELCB setting must be greater than 30 milliampere. These are the thumb rules what you need to check at your installation. If you are using VSD up to 5 kilowatt, the ELR setting must be greater than 300 milliampere. And for the motor greater than 5 kilowatt, you must have to follow the vendor guideline. Otherwise, unwanted nuisance tripping will generate into high production loss, or it may deteriorate your asset. So these are the three major settings I have mentioned for the kind user. So this is the importance of the eye leakage. Eye leakage has two major components. One component is peak value and second is true RMS. Thank you. Dhanyawad. Be with me.